Tired of using static credentials in your Terraform Cloud deployment? In this episode of Terraform Tuesdays, we'll look at how to use dynamic credentials to authenticate to your cloud providers. What's up, everybody? This is Ned Bellavance, nedinthecloud.com, and welcome to another episode of Terraform Tuesdays. As I mentioned in the introduction, we are going to take a look at dynamic provider credentials in Terraform Cloud. Now that sounds vaguely familiar. That's because I did a similar video back in October of 2022, just after HashiConf Global. Speaking of which, HashiConf Global 2023 is right around the corner, so if you haven't picked up a pass yet, I highly recommend going out and doing so. Now, when they announced the new feature at HashiConf Global, it wasn't yet available. Using some insider knowledge and a little bit of elbow grease, I had hacked together a solution that used the Workload Identity Token that is issued to the runner when it starts up. But that's not the official way to do it, and HashiCorp has made it easier to integrate with the big cloud providers. So I thought this time around, we'd take a look at the updated process for using dynamic credentials using Azure. Do I really need to get on my soapbox again about this? Probably not. Suffice to say that using static, long-lived credentials it's not a great idea. They can be reused, they can be stolen, and they can be misused. Dynamic credentials with narrow scoping can control who uses them, where they use them from, and how long they're valid for. It's that zero trust thing that you have heard people talking about. The bedrock of dynamic credentials is identity. If you can prove who you are using a trusted source, then you can get a temporary credential. Otherwise, no dice. So what is this identity in the context of Terraform Cloud? Terraform Cloud and Terraform Enterprise can generate a workload identity token for each run that is executed by a cloud runner. The token carries with it information about who generated the token, what type of run is being executed, and from which workspace and project it was executed. It also specifies the target audience, which would be the cloud provider in question. The workload identity token is passed from the runner to the cloud provider, who then performs a verification of the token. First, it makes sure that the information in the token comes from a trusted source, which in our case is going to be Terraform Cloud, and that the token has been signed by that entity. Then it checks the subject claim against a security identity, an Azure application in our case, making sure that the subject and audience information match. If all that lines up, Azure will generate a temporary credential that is scoped to the permissions of the identity. That credential is then used to perform the actions in the Terraform plan or apply phase. Once the run is complete, the credential will be discarded and eventually expire. Every subsequent run will generate a new temporary credential. You don't have to worry about leaked credentials or credentials being reused indefinitely. It's a much more secure way to authenticate to your cloud providers. So let's get it set up. I've already taken the liberty of configuring Azure and Terraform Cloud. If you'd like to follow along, a setup Terraform configuration is available in the Terraform Tuesdays repository, specifically in the directory 2023-09-12 TFC Dynamic Identity. There's two directories in there, one for setting up multiple instances of a provider and one for setting up the single instance of a provider. We're going to start with the single instance since it's a little bit simpler. The first step is to configure Azure Active Directory with an application and service principal. Now, if you know anything about Azure AD, you'll know the weirdness that is the application and service principal. If you don't, just trust me, you create an application first and then a service principal. The configuration that I ran created an Azure AD application that we can see here. If we look in the properties of the Azure AD application, we can create one or more federated identity credentials. Each credential will have its own issuer, audience, and subject. The issuer in our case is Terraform Cloud. The audience is API Azure AD Token Exchange by default, and I wouldn't recommend changing it. The subject is going to be a combination of the organization name, project name, workspace name, and run phase. Now, Azure doesn't allow for wildcards in the subject, so you have to specify the exact subject for each credential. What does that mean? It means that if I try to use the same federated credential for a different workspace, the claims will fail and no credential will be issued. It also means that if I move my workspace to another project, I will need to update the subject for the federated credential. And if I want to use the same credential for the plan and apply phases, I will need to create 2 federated credentials, one for each run phase, which is what you're seeing here. All the federated credentials here are using the same Azure AD application and service principle. So you can reuse this account for a bunch of workspaces or create a new one for each workspace in your organization. It's really up to you. That's it for the Azure Active Directory side, but right now our service principal is associated with our application, but it has no rights to do anything in Azure. So I granted it contributor rights on a subscription. That's the subscription we'll be using to deploy a configuration later on. Next, we need to configure the Terraform Cloud side of things. You may have noticed in the subject for the federated identity that the project was Dynamic Identity Project and that the workspace was Dynamic Identity Azure Workspace. The configuration that I deployed created both the project and the workspace, and sure enough, I've got both of those configured in Terraform Cloud. Inside of the input variables for the workspace, we need to configure some environment variables to let the runner know what type of token to request. The first one, TFC Azure Provider Auth, set to true, signals that we are authenticating to Azure. The second one, TFC Azure Run Client ID, describes the client ID associated with our Azure AD application. We also need to configure the Azure provider to use a specific tenant and subscription. You can set that with environment variables, like we did here, or through Terraform variables and add entries to the provider block. We'll revisit why you might want to do that later. That's it for the Terraform Cloud configuration. Let's get this workspace linked to a Terraform configuration in GitHub. We've got our federated credentials set up in Azure Active Directory, permissions granted to an Azure subscription, and the right environment variables set in the Terraform Cloud workspace. Now we need to link the workspace to a Terraform configuration. Over here in GitHub, here's the configuration that we'll use. It simply creates an Azure resource group and a virtual network. Note, if we look in the terraform.tf file, the Azure RM provider block doesn't have any arguments like use OIDC or OIDC token. That is going to be taken care of by the Cloud Runner, and it knows that because we specified the environment variable that corresponds to an Azure authentication. You also shouldn't set the equivalent environment variables for use OIDC or OIDC token either. Heading over to Terraform Cloud, we'll go into the settings for the workspace and link it to a VCS provider. I've already got GitHub linked, so I'll select that and then select the repository. The branch in question is going to be called Dynamic-Identity, so I'll update the VCS settings to specify that branch. After saving the settings, it will automatically queue a plan, but that plan's going to fail because we're missing a value for the Terraform variable called prefix. I'll go into the variable settings and create a new variable, setting the prefix variable to the value taco wagon. Then I'll save the variable and queue up a new plan. This time, the plan should succeed. Let's take a look at the run. Now, I have auto approved turned on, so it will automatically apply the plan, assuming that the plan is successful. And if we look at the results of the run, we can see that it created the resource group and the virtual network successfully. Awesome. We have successfully used dynamic provider credentials in Terraform Cloud to authenticate to Azure. But what about other providers or multiple instances of the same provider? Let's see how Terraform Cloud handles that. Right now, Terraform Cloud has specific settings and environment variables for Azure, AWS, GCP, and Vault. Kind of the obvious ones. If you want to use dynamic credentials for another provider, you can use the environment variable TFC workload identity audience and set it to the audience of your provider. The token will be available in the runner under the environment variable TFC workload identity token. You can then use that token to authenticate to your provider, assuming that they have OIDC support. If you're using self-hosted cloud runners, you'll have access to include custom run actions to do whatever you need to make that token work with your particular provider. Sometimes you have to install additional software or run some bash commands. Custom run actions let you do that. Maybe I should cover that in a future video, since they are now available on the free tier. Well, anyway, that covers custom providers. But what about multiple instances of the same provider? Let's take a look at that. What if you need to deal with multiple subscriptions and different credentials? You could handle that on the Terraform configuration side with provider aliases, but how does that work with dynamic credentials? Wouldn't it use the same Azure AD application for each instance of the provider? Yes, it would by default, but there's a way to change that. On the workspace side, you would set the environment variable TFC Azure Provider Auth with the alias name appended. So if my provider alias was security, the environment variable would be TFC Azure Provider Auth Security and set it to true. Same thing with the TFC Azure Run Client ID environment variable. Append the alias name and set it to the client ID of the Azure AD application for that instance of the provider. The runner will then create multiple tokens, one for the default provider and one for each alias. Now, Terraform Cloud is going to need to pass that token information to each provider configuration, and it does so with an input variable. In your configuration, you will need to create an input variable called TFC Azure Dynamic Credentials with the following schema that you see here. And then, over in the provider blocks, you'll add 3 arguments: use OIDC, client ID file path, and OIDC token file path. The value for the latter 2 will use the input variable you created to look up token information based on the alias name. Here's where you could set a different tenant ID and subscription ID for each provider instance using input variables. See, I told you we'd come back to that. It does seem a little convoluted, I agree, and I'd like to see simpler support that doesn't require altering the existing configuration, but it does work. And it does allow you to use multiple Azure AD applications for a single configuration with dynamic credentials. Other providers like AWS and Vault have similar support for multiple instances of the same provider. I've included an example of this in the Terraform Tuesdays GitHub repository. It's a little more complicated to set up than the previous example, but it does work. If you know me, you know I'm no fan of static credentials. Dynamic credentials are a much better way to authenticate to your cloud providers. And now that Terraform Cloud supports dynamic credentials, it's easier than ever to use them. Are you using dynamic credentials? Got some questions or a weird use case? Let me know in the comments below. And if you like this video, give it a thumbs up and subscribe to the channel. Thanks for watching. Until next time, stay healthy, stay safe out there. Bye for now.